This is an HK-450. It's a clone of the Align T-Rex 450 SEV2 from 2011. The model was designed to perform aerobatics, so if the rotor spins quickly enough, it can actually carry a significant amount of weight. At a minimum, the rotor can produce in excess of 1 kilogram of force, and with a ready-to-fly weight of 700 to 800 grams, the aircraft has a range of payloads between 200 to 300 grams. This is roughly the same mass of an average smartphone, so we can actually use one as a makeshift camera for aerial footage. While looking at the model in flight, it actually appears quite smooth and vibration-free. However, once we actually mount a camera onto the aircraft, we notice that the video quality is terrible. The image is highly distorted and appears smeared and blurry. This is known as the jello effect and is caused by high-frequency vibration. And there are many sources of vibration in this aircraft. The main rotor, the tail rotor, the motor, and the belt that drives the tail rotor. Under these conditions, it seems reasonable why the video quality is so poor. To improve the video quality, we can suppress some of these vibrations through passive means. A simple solution is to mount the camera using springs. While this acts as an effective cushion, it can lead to underdamped behavior, where an initial disturbance takes a long time to decay and settle. This is certainly undesirable as it will cause the image to wobble back and forth. We can attenuate this underdamped behavior by selecting an appropriate material. Leather is a good choice as it's elastic and is not as undamped as spring steel. As a consequence, if we mount our camera on a platform supported by this material, it will be much less susceptible to prolonged wobbling. Since we're using a smartphone as a camera, we can redirect its image by using a mirror. This allows us to easily attach the phone to the anti-vibration mount. Even with the additional mass of the mirror, the response of the platform is still highly damped. Through this flexible mount, we have essentially made a mechanical low-pass filter. We can easily demonstrate how this suppresses vibrations by using a spring and a mass. At low frequencies, we can see how the mass closely follows the displacement of the spring. If we increase the frequency of the displacement, we notice the mass is much less affected by the oscillation. If we continue to increase the frequency, we notice that the mass essentially doesn't move in the direction of the displacement. We can observe the same behavior in the camera mount. If we rotate the helicopter slowly, we can see that the camera follows the motion. However, once we shake the helicopter, the camera mount will begin to bend. So how well does this actually work in practice? Well, it actually works pretty good, especially considering how simple the anti-vibration mount is. Granted, the video quality still isn't great, but it's significantly better than when the camera was rigidly mounted to the helicopter. It's still a little blurry and has a lot of rough motion, but a lot of this can be removed by digital stabilization. With more fine-tuning of the spring and damping properties of the anti-vibration mount, it's likely that the image quality can be greatly improved, especially if the springs are made much softer, such that only very slow motion is transferred from the helicopter to the camera. Ultimately, this experiment serves as an example of how simple mechanical solutions can yield good results for little effort. From here onwards, there's some additional footage of the aircraft flying around, since I think it looks cool, especially the high-speed passes. For such a small and relatively lightweight model, it can actually fly quite fast.